is online based itself, I guess. It is saved in automatically in chat history.
Now I have started the recording. Okay.
Okay, okay.
Hello. Yeah. The slides are visible now. So so today we are discussing about the various surface analysis techniques. So today we are uh, just getting the introduction of what all these techniques and why we need these techniques, and what are the roles of various process parameters like that we are going to discuss today. So first thing which comes into mind is what is so interesting about the surfaces. So why we always focus on the analyzing the surface, even if there is any mechanical impact or any electronic bombardment or any other irradiation because of some X-ray, gamma rays. So what happens when there is any impact or anything happens to the material, the first contact will happen on the top surface only, and from that surface we try to get the idea about the what actually happened to the our sample. So that's why it is very important to get the idea about the surface. And always when we say about zero thickness layer, we doesn't mean that we are just only focusing on the top surface. Sometimes we do some depth profiling which vary from some nanometers to micrometers, and with that we try to get the more idea about the in-depth surface. But scientists used to say that it is a surface analysis because with time, with the depth profiling, we constantly try to analyze the different layers at different instant of thickness. So so actually, when we talk about the surface analysis, what we are actually going to measure in the surface analysis. So first thing is surface morphology, means when we have performed any treatment, heat treatments, or there's some ionic bombardment or electronic bombardment or X-ray irradiation. So what happens then there is a change in the grain structure or the morphology of the surface. So it gives some idea that what actually happens to the material during that treatment or the during that treatment or the analysis, performing that analysis, whether we are doing some X-ray analysis or like that. So, and second thing which is very but obvious, that we are try to analyze the composition, what variation came in during the composition. So in my case, if we see, I performed that laser heat treatment, and because of that oxides forms, and these oxides plays a major role in the color formation. So it's very obvious to get the composition of oxides which are formed during the laser heat treatment, and that plays a very important role in getting the idea about the what actually happened to the surface. Apart from these things, we with different techniques we try to analyze other characteristics also, like hardness, friction coefficient, roughness, electrical conductivity, and many more characteristics. But in this course, our main focus is to get the idea about different techniques to analyze the surface morphology and the composition. So when I started performing these post processing, then I was so confused that why there are so many techniques. We get the composition from EDS also. We get the composition from this XPS analysis also. We can also get the composition from Raman spectroscopy. So why we need so many techniques and to get same thing? So actually, what is there? Every method has some advantages and disadvantages. Whether they may be giving same thing, but they are limited, they have some limitations and they have some advantages. So what happened, every researcher according to their needs have modified the various methods. So primary methods are very few, but after each modification so many new techniques develop. So let's say in this case, so here you can see there is an electron beam which is coming on the surface. So we are just using electron beam to analyze the characteristic about the surface. But because of that electron beam, you can see there are so many things happening to the sample. Let's say there is some emission of that secondary electrons, back scattered electrons, or characteristic X-rays are also coming out, or some auger electrons are also coming out. So there is a combination of that elastic scattering and the inelastic scattering. So that's why it's actually depend upon the technique, that what you are actually analyzing. So sometimes if we in, as you know, in SEM, sometimes we analyze secondary electrons, or sometimes we analyze back scattered electrons. So if you have ever performed this SEM analysis, you came to know that there is a very less difference between these electrons. They perform the similar analysis, but the variation in result is very much. So what is actually difference between the, so in the case of that back scattered electrons, we know there is a elastic interaction, but in the case of secondary electrons, it is mainly inelastic scattering. So generally we use this secondary electrons method to get the more idea about the surface information. So like this, you can see with the single electron beam, we are getting so many different types of electrons, or the X-rays, or different conditions are forming, and it depends upon what we actually need to analyze. So if you want to analyze some this auger electrons, there's a different method. If you want to analyze secondary electrons, there's a different method. Like that, so many methods developed. So actually, when we have to analyze, first we have to make an impact on the surface with some other source, like we do some irradiation with the X-rays, or ions bombardment, or the electrons bombardment, or some other heating or anything, and we after that we try to record the signals what is coming out of the surface. So by these process, we try to get the knowledge or the idea about the what we actually want to gain from the process. So, so here you can see there are so many different processes, and in the surface analysis, two things are very important. One is that volume sensitivity, and other is spot size. So volume sensitivity and spot size are actually inverse of each other. Like if we want to give a very sensitive analysis or some very in-depth analysis, we generally try to have a very minimum spot size to get the in-depth knowledge about that process. But in some cases, we don't need some sensitive analysis. We need to analyze the whole material. Then we increase the spot size. So here you can see that there are different methods which are used to perform different analysis, and with each method have some limitation, whether is on volume sensitivity or on spot size. And if you want to get both these very perfectly, then the factor of cost may also come into play. So let's say we have a spot size like this, and we are with the some spot size, we are trying to analyze this much a cylindrical size. So in this we have a some diameter of 10 nanometer and height of 10 nanometer, and we are trying to analyze the atoms which are present in this cylinder. So if we calculate some number of atoms, let's say we have 10,000 atoms present inside this cylinder. So if we consider one atom for analysis among these 10,000, so we say that we are analyzing 0.01 percentage of concentration only. So that is actually thing, means if you increase the size of spot size, then you are analyzing large number of atoms, and among that we take some minimum. So here you can see that there's a this is a detection range. So means 100% atomic percentage analysis, and it decreases from parts per million and parts per billion and parts per trillion. So it depends how sensitive analysis you are doing. we choose a method according to that, and according to the detection rays we choose our spot size. And another thing that the uh, what is matter is the how much depth you want to analyze. So in some processes are only on the for the top surface, but some processes are used for analyzing the in depth about the surface. So here you can see some are only focused like AFM, AES, XPS are only on the top surface or near surface, means up to 10 nanometer they can analyze. So, but there are some methods like these SEMS, XRD, XRF, they can go up to depth more than 2000 nanometer. So that is also very important condition, that what you want to means up to what depth you want to analyze. So here we can say means for every different process there are some limitations and some advantages. We have to choose wisely that which process is suitable for our analysis. So in this course, actually what we are trying to get is what is the most fundamental and the most frequently used methods. So there are some methods which are most frequently, and from that that techniques, other techniques develops, and from for these techniques we will try to analyze what is the working principle and the device schemes, and then what are the these features and abilities of these techniques, and what are their advantages and what are their limitation. And the end we will try to analyze what's actually we are getting from the results. Means we performed that analysis and we got some results. So what we results we can expect from that analysis, and how can we interpret the results from that analysis. So this is a course outline for this method of surface analysis program. In this, today is a just introductory lecture, and from next lecture, which is scheduled on 13 July, we will study about the electron beam techniques. So in that, we will mainly discuss about the SEM and EDS. And after that, so actually we are mainly analyzing four types of techniques. One is this electron beam techniques, other is this X-ray techniques, then optical techniques and scanning probe and ion beam. So what's actually difference in between these techniques? That the energy source is different. For SEM, EDS, these TEM, we are mainly using that electron source as a that energy gun, and for this XRD XPS we are using this X-ray uh, that energy source. Like that, there are different techniques. For ion beam we use some uh, noble gases like argon, helium, like that. So with that, we try to analyze what's actually specific about these processes, and we will try to analyze how to get the idea about the results and what we interpret from that results. So in the next lecture, we will focus on that SEM and EDS. In that, we will try to understand about what is the basic working principle of that, and how we diagnose the received electron signals. Means if we have bombarded the sample with some electron signals, then what analysis we can perform that, and what are the parameters to control that electron signal. And we will try to understand create some in-depth understanding about depth of field, image resolution and beam size. And we will after that we will try to differentiate between the SEM, FESEM and EDS analysis, and what are the different advantages and technique advantages of these techniques and their limitations. And after that I will try to show some of the results which I obtained using these three techniques, and we'll try to work on how we interpret the results using these techniques. Thank you.
Thank you, Ankit, for this very informative session on surface analysis. That was